Our solar system is one of over 500 known solar systems in the entire Milky Way galaxy. The solar system came into being about 4.5 billion years ago when a cloud of interstellar gas and dust collapsed, resulting in a solar nebula, a swirling disk of material that collided to form the solar system. The solar system is located in the Milky Way's Orion star cluster. Only 15% of stars in the galaxy host planetary systems, and one of those stars is our own Sun. Revolving around the Sun are 8 planets. The planets are divided into 2 categories based on their composition: terrestrial and Jovian. Terrestrial planets, including Mercury, Venus, Earth, and Mars, are primarily made of rocky material. Their surfaces are solid, they don't have ring systems, they have very few or no moons, and they are relatively small. The smallest and closest to the Sun is Mercury, which has the shortest orbit in the solar system at about 3 Earth months. Venus is the hottest planet, with temperatures of up to 867 degrees Fahrenheit due to an atmosphere of carbon dioxide and extensive lava flows. Next to this world of fire is a world of water, Earth. The water systems on this planet help create the only known environment in the universe capable of sustaining life. The last of the terrestrial planets, Mars, might have also supported life about 3.7 billion years ago, when the planet had a watery surface and moist atmosphere. Beyond the 4 terrestrial planets of the inner solar system lie the Jovian planets of the outer solar system. The Jovian planets include gas giants Jupiter and Saturn and ice giants Uranus and Neptune. The gas giants are predominantly made of helium and hydrogen, and the ice giants also contain rock, ice, and a liquid mixture of water, methane, and ammonia. All 4 Jovian planets have multiple moons, sport ring systems, have no solid surface, and are immense. The largest Jovian is also the largest planet in the solar system, Jupiter. Nearby is Saturn, the solar system's second largest planet. Its signature rings are wide enough to fit between Earth and the Moon, but are barely a kilometer thick. Past Saturn are the ice giants Uranus and Neptune. The slightly bigger of these ice giants, Uranus, is famous for rotating on its side. Next to Uranus is Neptune, the outermost planet in the solar system and also one of the coldest. Orbiting the terrestrial planets is the asteroid belt, a flat disk of rocky objects full of remnants from the solar system's formation, from microscopic dust particles to the largest known object, the dwarf planet Ceres. Another disk of space debris lies much further out and orbits the Jovian planets, the icy Kuiper belt. Apart from asteroids, the Kuiper belt is also home to dwarf planets such as Pluto and is the birthplace of many comets. Beyond the Kuiper belt is the Oort cloud, a vast spherical collection of icy debris. It is considered the edge of the solar system since that is where the gravitational and physical influences of the Sun end. Our solar system's particular configuration of planets and other celestial objects, all revolving around a life-giving star, make it a special place to call home.
surface, there's a scorching ball of iron, surrounded by an ocean of boiling hot liquid metal, the Earth's core. It's as toasty as the surface of the sun, with enough heat to brew more than 1 trillion cups of coffee per hour. That's over 100 coffees for every single person on the planet. What if this sizzling core suddenly cooled down? Could our planet still function with a frozen core? Or would we just become another lifeless rock orbiting the sun? This is What If, and here's what would happen if the Earth's core cooled down. Ever since it was formed, the inner core of the Earth has been losing heat, but it's still blazing hot, around 6,000 degrees. Of course, no one has ever been to the center of the Earth. The unbearable heat is one of the reasons you don't want to get any closer to it. If only it cooled down a bit, maybe we could go and see what's inside our planet, and if all our guesses about the Earth were right. There are many things on Earth that make life possible. Our geomagnetic field is one of them. It protects us from all kinds of space radiation, including highly charged particles constantly blasting from the sun. The magnetic field acts as a shield and deflects them around our planet. That way, no solar winds can strip away our atmosphere, which is also an essential element for life here on Earth. And guess what? This magnetic field is generated by the Earth's core. As the planet spins, the two parts of the core, the inner solid core and the outer liquid one, move at different speeds, generating electric currents. Those currents generate our geomagnetic field. If the Earth's core cooled down, it wouldn't produce any currents. The Earth would lose its magnetic field. If that happens, be ready for all kinds of bad things. Because no magnetic field means no atmosphere. And no atmosphere, well, in short, the Earth would start looking a little more like Mars. No breathing exercise could calm you down, since you wouldn't even be able to breathe without a pressure suit and an oxygen mask. Since the frozen core wouldn't heat up rocks, water, gas, and other geological material anymore, the Earth itself would be getting colder and colder. On the other hand, volcanoes would no longer be spewing lava, continents would stop drifting away from each other, and earthquakes would completely disappear. Nobody could survive on that Earth for too long, but it would be a good simulation of life on Mars. Who knows, maybe we'd have enough time to pack up our stuff, jump on a spaceship, and get off of this planet before it became absolutely dead. But if someone very curious decided to stay on Earth and to finally drill a hole into the core, try to convince them not to. The core may have lost all its heat, but the pressure there would still be 3.5 million times higher than it is on Earth's surface. Anyone bold enough to go down there would be squeezed into the core, becoming one with the Earth, literally. Looks like the planet's core would be better off if it remained as blisteringly hot as it is. And maybe drilling through the Earth isn't the best idea either. But that's a question for another What If.
Earth and the sun, blocking some or all of the sun's rays from reaching the Earth. By cosmic chance, even though the sun is 400 times wider than the moon, it's also 400 times farther away. Therefore, the two objects appear the same size in our sky. Astronomers are able to predict eclipses because the Earth and Moon have very predictable orbits. Why then isn't there an eclipse every month? The Moon's orbit is usually tilted a few degrees north or south in relation to the Earth. When the Moon does eclipse the Sun, it casts two types of shadows on Earth: a smaller, darker shadow known as the umbra, and a larger shadow known as the penumbra. There are 4 types of solar eclipses. The first and most spectacular is a total eclipse, when the moon completely covers the sun's surface. A total eclipse can only be seen if you're standing within the umbral shadow. That's why the imaginary line created by this shadow as it races across Earth is known as the path of totality. People within the penumbral shadow see only a partial eclipse, the second type. From this view, outside the path of totality, the moon passes in front of the sun off-center, never fully covering its surface. Third, an annular eclipse occurs when the moon passes directly in front of the sun. However, unlike a total eclipse, the moon appears too small to fully cover the sun. The moon's orbit is elliptical, so sometimes it's closer to Earth and sometimes it's farther away. Last, a hybrid eclipse is when the moon's position between the Earth and sun is so finely balanced that the curvature of the Earth plays a role. The moon will be farther away from some parts of Earth along the eclipse's path, resulting in an annular eclipse. In other parts, the moon will be just close enough to fully cover the sun, resulting in a total eclipse. While a total solar eclipse happens somewhere on Earth every year or two, any given point on Earth experiences the event only about once every 400 years. We interrupt this video for an important safety announcement. Looking directly at the sun, even during an eclipse, can cause permanent eye damage. Fortunately, there are ways to enjoy an eclipse safely. The easiest is to use certified eclipse-watching glasses, which are shaded thousands of times darker than typical sunglasses. You can also look at the eclipse indirectly by making a pinhole viewer. Simply poke a small hole in a piece of cardboard. Hold the cardboard up to the sun, allowing the sun's image to be projected onto a flat surface. Be sure to look only at the surface and not through the cardboard. Just before the moon completely covers the sun, low-lying valleys on the moon's edge will be the only spots that sunlight continues to pass through. These remaining brilliant shafts of light, known as Bailey's beads, will disappear one after another. And finally, a single bead of light remains, known as the diamond ring, signaling that you're just seconds away from experiencing totality. Once the last bead disappears and the moon completely covers the sun's surface, the view through your eclipse glasses will be pitch black. Totality achieved. At this point, none of the sun's rays are reaching your eyes, and it's the only time that it's safe to take off your glasses. Remember to put your eclipse glasses back on before any of the sun's rays start to peek through again. Any sunlight reaching your eyes, even for a few seconds, can cause serious damage. While an eclipse can last a few hours, totality typically occurs for less than 3 minutes. Animals and plants have also been known to alter their behavior during a total eclipse. Songbirds may stop singing, crickets may start chirping, and flowers may even start to close up. We won't always be able to see total solar eclipses. The moon moves about 1.5 inches away from Earth each year. It's estimated that in about 1 billion years, the moon will be too far away from Earth to completely cover the sun. A lunar eclipse happens when the Earth blocks some or all of the sun's direct light from reaching the moon. This cosmic event only takes place during a full moon, which happens once every 29.5 days, or the length of one full orbit of the moon around the Earth. So why don't we have an eclipse every month? The moon's orbit is tilted a few degrees in relation to the Earth, so the Earth, moon, and sun don't always align. When the Earth does eclipse the sun, it casts 2 types of shadows on the moon. A larger shadow, known as the penumbra, and a smaller, darker shadow known as the umbra. There are 3 types of lunar eclipses. The first is a total lunar eclipse, when the sun, moon, and Earth are in perfect alignment and the moon falls within the Earth's umbral shadow. Total lunar eclipses are the most striking of the 3 types because they turn the moon a sunset red. While shorter blue wavelengths of light are scattered outward by the Earth's atmosphere, longer red wavelengths are refracted or bent inward toward the moon, making it appear red. The brightness of the moon's red glow depends upon how much dust and clouds are in the Earth's atmosphere. Following volcanic activity, ash can block out enough light to render the moon a darker red or even near black. A partial lunar eclipse, the second type, occurs when the Earth, moon, and sun don't perfectly align, so only part of the moon passes into Earth's umbra. Earth's shadow appears very dark on the side of the moon facing Earth. Last, a penumbral lunar eclipse occurs when the moon passes through Earth's penumbral shadow. The event is so subtle that most people don't even notice. The moon will appear just slightly darker than normal. Lunar eclipses occur up to 3 times a year and can be observed from the entire nighttime half of the Earth. Unlike during a solar eclipse, it's safe to look at the moon with the naked eye during a lunar eclipse. It is only because of the distances of the sun and moon from the Earth that we are able to witness total lunar eclipses. As the moon inches away from the Earth each year, one day, billions of years from now, the moon will be too far away to fall completely within Earth's umbral shadow. Until then, we can occasionally enjoy seeing our own planet's shadow cast upon the largest object in the night sky.